So welcome to the Maths Senior Phase with Sharp ELW535 SA calculator. We are going to be doing quite a lot of things tonight. Hopefully they shouldn't take longer than an hour. But if you get stuck anywhere or you have any questions, feel free to jump in on the Q&A side. It looks like the chat function is disabled, so Q&A is where we want to be at. Okay, cool. So this session is being recorded and will be uploaded to YouTube either on Friday or on Monday, so you can go and rewatch it if you would like to. I'm also happy to send the PowerPoint presentation to you if you do have any questions. So if there are any, so these are all the links that I like to share with teachers of all the worksheets that you can find and resources. Most of them are free, so eClassroom is the only one that's got quite a hefty subscription. However, Twinkle, who have recently started doing content development for, have grade 1 to 9 worksheets available for a subscription of 39 Rand a month. However, if you are a student teacher in your last year of teaching, you can email me and I will send you a special code for your practical in this term. So give me a shout if that's one of you. So some quick basics here. So we've got the on button. We've got the second function button, which is this orange one here, and that just gives you access to all of the orange functions. You have your alpha button, which is this blue key here, and that accesses your statistics and your memory keys. You've got mode, which gives you access to the 4 different modes, and I'll explain that in a little bit. And then, of course, BS is for backspace, and it means delete. Change will change the way that your answer looks. It will change between mixed, improper, and decimal. And then, of course, your equals button, which will show you what your answer is. Okay, so there are 4 different modes on the calculator: normal, stat, table, and drill. So normal does things like fractions, probability. We've actually got a dice function on the calculator for you. Trigonometry is not important in grade 7 to 9. I will show you, however, a shortcut for Pythagoras. And then, of course, your stats. I'll just go through the basic univariate data stats with you. In other words, the type of statistics where Mary's maths box are, and they give you a list. Okay, table mode, where we'll talk through finding facts, pairs of a number, and then, of course, drill mode, which is practice for mental maths. So what's really, really nice on the calculator here is that you actually have a mental maths function, and I'm going to show you that now. So I'm going to press mode and then 3 for drill. And we're going to press 0 for math. And then you're going to choose. You have 25, 50, or 100 questions, and you can use your up and down arrow keys to decide how many questions you want to do. Then your left and right arrow keys choose the type of questions you want to do. So plus, minus, times, divide, or all 4 of these. Now, the number ranges are appropriate for grade 3 and up. In other words, 0 to 20 plus 0 to 20. Minus is the opposite. Times is 0 to 12 times 0 to 12. So that's grade 5. And then division is obviously grade 6. No, is grade 5 as well. And also it's the opposite of multiplication. So what happens is the calculator is going to ask you a question. It's randomly generated, so it will always be a new set of questions. You then type in the answer. You press equals. It will give you a tick if you are right, and a new question. If you get the answer wrong, it's going to mark it wrong and repeat the question again. And it's very patient. It's going to keep asking you until you get the question right. Okay, so you can see here, lots of patience. However, it doesn't make sense for a student to spend a long time trying to answer a question if they don't know the answer. So they can also ask the calculator for help. And to do that, they leave the space blank and they just press equals, and it will then show them what the answer is. Okay, so next time they see 110 divided by 10, they know that the answer is 11. So they can learn from their mistakes. Now at the end, I am going to cheat here a little bit. You see, I won't get any marks for this, and I'll show you proof of that at the end here. I don't want to jump too fast. One last question, and then it'll say press enter. So you press your equals button and it will tell you got 2 marks correct out of 25, or 8%. So this is a really nice way to practice mental maths with your students without you having to do any marking yourself or setting up any tests. And because the questions are random, they can practice them a lot. Now, I used to have a set at the math center that I ran, and the students would actually come on the days they weren't supposed to be there just to play with my set of calculators, because they wanted to make sure that they got the questions right. Quite competitive, but it did help that there were sweets in the drawer if they got 100%. So yeah, okay, let's talk finding factor pairs. So one of the other cool things that you can do is to use the calculator to find factor pairs of a number. So to do that, we're going to use table mode, and I'm going to look for factor pairs of 48, for example. So you press 48, you press your fraction button, and then you make an X by pressing the RCL button twice. So there you go. I've just moved it. You don't have to. I've just moved it so you can see how it looks nicely. Okay, press equals, and we'll leave function 2 for now. Press equals, and we'll see start and step. So we just gonna again leave them as is, and of course now we have our factor. Anything divided by 0 is undefined, and that's this little stripy line here. So in grade 10, undefined becomes an asymptote, which they literally represent on the graph as a stripy line. So that's the reason that the stripy line was chosen. And then of course all your factor pairs are here. 1 and 48, 2 and 24, 3 and 16, 4 and 12, 5 and 9.6. So we can see 5 is not a factor because it has a decimal answer. So we can get 6 and 8, 7, and a big decimal answer. So we can see that obviously 7 is also not a factor. And then we've got 8 and 6. So we can see that 6 and 8 and 8 and 6 are the same. So we have found all our factor pairs, and we are now done. What's really nice is I got a question the last time about how big a number can you look for factor pairs of, and really the answer is as big as you like. Your table is unlimited, so you can go for as long as you like, and you're not going to run out of space. And even though we started at 0, I sent myself very far. Even though we start at 0, it doesn't matter because you can do the negative side. So there's no limitation on your table in terms of value substitution. You can go in either direction for as long as you like. Pretty cool, right? You can also find multiples using the table mode. So let me show you here. So say, for example, we wanted to find multiples of 27. So you're going to press on twice, and then we can press 27. And then again, we're just going to make an X by pressing RCL twice, and then equals, 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 equals. And here are all of our multiples. So 1 times 27 is 27. 2 times 27 is 54. 3 times is 81. 4 times is 108. And again, your table is unlimited, so you can find multiples for as long as you like. Now, this is really nice for doing long division questions with your students. And here is my example. So I'm going to make my calculator smaller firstly, and then I'm going to reshare my screen with you so that you can see both my example and my answer. Okay, so I've gone a bit far down here, but just scroll back up to the more reasonable value and grab a pen. Okay, so we've got 800. On, so it'll make it easier for me to write with my mouse. You'd think after all of these webinars I'd be better at this, but no. All right, so we can see 27 doesn't go into 8, but we can check for 27 goes into 89. Now on the table, we can see that we've got 27, 54, 81, and the next value is 108. So in other words, 27 goes into 89, and it has to be less than 89. So it's going to be 81, which is 3 times, right? So here's our pen. So we're going to write 3 times as we've got daddy, mommy, sister, brother. So we've done daddy divide. Mommy says multiply, which is 3 times 27, which we've got quite easily from our table, which is 81. Then sister says subtract, so 8 there, nothing there, bring down brother says bring down the 6. And again, we can see that we've got 86. So it's going to give us the same answer, which is 3. We'll do this whole thing again, minus 5, nothing, bring down the 1. Now we go look for 51. And if we scroll our table again, you can see 54 is too big, so it must be 1, which is 27. So we're going to write down a 1 here. Sister says 27. We're going to have to do some borrowing. So that becomes a 4. 11 minus 7 is 4. 4 minus 2 is 2. So our remainder is 24. So this table method is a nice way to do multiples for students who particularly struggle with adding multiples together on their own as well. Awesome. Any questions so far? We all good? All right, fantastic. Just remember to chuck them into the Q&A function, and I can answer them. Now, another nice thing, and particularly nice for grade 8 and 9, is your highest common factor and lowest common multiple function. So to use those, we have to press home, and home just takes us back to normal mode from whichever mode we were in before. Now, let's say, for example, we want the highest common factor of 60 and 72. So we're going to type in 60, press second function and 2, and then type in 72, and then you can press equals. What's really nice here is that you can put as many numbers as you like into the calculator to find your highest common factor. There we go. And so you'll see that basically you can fill up until you run out of characters for finding the highest common factor, which when I did the test was about 60 different numbers, which is pretty crazy. No one's going to get there. So you can see you really have enough space to do as many as you need. You can also do the lowest common multiple. And again, we would just use second function, and this time 3, and then 72, and equals, and we can see that that's our lowest common multiple. Again, you can put as many numbers as you like into your LCM search. So for example, if we were looking at this from the perspective that these are our denominators, we could find our lowest common denominator where these are the denominators as well. So LCM and LCD are basically interchangeable. So this is a really nice way to help with adding and subtracting fractions without using the calculator to do that calculation. Now, we've also got a prime factorization, and I'm actually going to use this value here. So we've got this answer, we've pressed equals, and then all we would do is press second function and exp. You can see above it in orange, it says pfat. So you press that, and it breaks down all of our exponents for us, as all of our prime factors as well. Okay, so if you want to do it from scratch, just press on, type in your number, and press equals, and then say second function and pfat. Now, if you have a prime number, you would type it in, press equals, and say a second function p facts. And what will happen is that that comma will go away at the back. And that's how you know that it is a prime number, because it doesn't give you any further factors as well. Sure, Bazika, I'll repeat the LCM for you, no problem. So again, your LCM function is on your number 3 button. So you would just type in the first number that you're looking for an LCM of, and then press second function and 3. And then you type in the next number you want, and then second function and 3 if you've got 3 numbers, and the next number. So it must be bracketed on either side by a number, and then equals. And there you go. So quite nice and easy and straightforward. All right, now for integers, just to take note of, when you're working with integers on the sharp calculator, you must remember that you have a minus and you have a negative value. So if, for example, you have 6 minus -3, that will work. But if you typed in 6 minus -3, what happens is the calculator assumes that you've made a typing error, and it will give you an error 1 for syntax. So it will take you back and say, you've put in too many minuses. So what you do need to make sure is that you use the negative and not minus negative, not minus, but minus negative when you do these sorts of calculations. All right, and then this is linked to a worksheet on Maths at Sharp for grade 7 and 8 integer practice. So if you're looking for a worksheet for your students, remember all of our worksheets come with step-by-step memos for you as well. Let's talk fractions. Okay, so when we want to add fractions, there are, firstly, if we're doing just proper fractions, there are 2 ways to input the fraction. The first is obviously to press your fraction button first, and then to type in your numerator, press down and type in your denominator, and then press your right arrow key to get out of the fraction. Okay. If the second way to do it is to type in your numerator first and then press your fraction button, and then to type in your denominator, and that will then give you your solution. So either way is fine. The second way is quicker if you know you're working with proper fractions, and you don't have to worry about whole numbers. Okay, and then of course change just changes your solution. So we've actually got here is a recurring decimal. So I'm going to jump ahead here and just show you how to set that up. So initially on the calculator, you don't actually have the recurring decimal. You need to turn it on. So to do that, you press setup and press your down arrow key and choose 5 for recurring decimal. And then you turn it on by pressing 1. So that will then give you that little bar above your recurring value. And it will give you both the, well, it'll give you your mixed number fraction, your improper fraction, your recurring decimal notation, and then of course your full decimal notation as well, so that students can see exactly what's going on there. Okay, percentages again. Now for this one in particular, I must hedge this. This is a particularly nice function for math literacy. If you are a math literacy teacher, I'm showing you this because it's a nice shortcut and it can be used to check answers. But students still need to be able to do all of the steps in order to get all of the marks for percentages. Okay, so now that I've prefaced that, when we look at finding percentages, right? Let's say, for example, we want to find 15% of 120 and add it to 120 to find out how much VAT or how much we would pay after VAT is added. So traditionally, we would say 120 times 15, and then we'd say second function 1 to give us percent, and that would give us 18. And we'd say 18 plus 120 gives us 138. Now, Sharp has created a shortcut where you can simply say plus 15%, and it will do that entire calculation for you straight away. So this is why I'm saying it's very nice for math literacy, but it is a good and it is a good way to check grade 8 and 9 work, but they still need to be able to show all of the steps while using the calculator. Okay. Now we spoke about recurring decimals, so I'm not going to obviously go any further than that. But I often get asked, can we change our answer or the way that our answer looks on the calculator? So the answer to that is yes, you can. And to do that, we press setup, we choose 2 for editor, and we choose 0 for write view. Now, your calculator is set up so that it gives you the exact answer. In other words, it gives you the fraction or the surd or the value with pi multiplied. So when you choose approximate, what happens is when you do any calculation with a decimal, it will give you the decimal answer first. And then if you change it, it will take you back to the fraction. So this is particularly nice to use when you're working with decimals a lot. And I'm thinking more along the lines of calculations with money, math literacy, where you do rounding off to 2 decimal point places and so on and so forth. So it's just a nice way to know the two. I'm going to change it back because otherwise my answers for the rest of the presentation are not going to make sense. I do want to go back to fractions because I haven't told you how to do mixed number fractions. So I'm going to show you that quickly. So when we talk about mixed number fractions, we can do, say for example, 7.5. We can type in the whole number first, and then press second function and your fraction button, and then type in a 1, press down and type in a 2. The alternative is to press your fraction button first, and then to move the arrow in front of the fraction, and then type in the whole number, and go back and fill in the rest of the fraction. So both ways work. The calculator assumes that you're adding the 3 to the fraction, unlike other calculators that assume that you are multiplying. So that's just the difference between the two. All right, great. And then, of course, you'll see if you've been looking at my calculator and wondering, when I have a fraction or a decimal, I have a comma in my solution and not a dot. And to change that, you would just say setup, press your down arrow key and go to 6. And then, of course, you can choose dot or a comma, depending on your preference. I'm going to go back to dots just for a change of pace here. I've been working with commas all day. So you'll see now in my solutions that you'll have a C with a comma. Okay. So any questions so far? We all good? Okay, happy? Okay, let's talk about exponents. So I think you cover exponents in term 2, but I just want to go back through this because it's a good reminder. So when we start teaching exponent rules, we teach them that when you multiply with the same bases, you add your exponents. So what we've actually done is created an investigation that you can download off Maths at Sharp. Just Google, just search in the search bar investigations, and it'll take you to the page where you can download the investigation with the memo. And we've done that for grade 8 and grade 9. Okay. And grade 7, I think, has got exponents as well. So what we would do is we'd have the same bases with different exponents, and we'd look at our answer. And if I prime factorize my answer, I can see that it gives me 2 to the 7. Now, the only way to get 7 is to say 3 plus 4, right? So if I did this, I said 3 plus 4, it should give me the same answer, which it does. So we can see that the rule has been proved for this particular one. So what we do is we then encourage the students to do quite a few using their calculator and to come up with the rule themselves. So what is the rule by looking at these answers? Okay. So these are all the steps here if you want to take a look and explain it to your students. Now, we also deal with scientific notation in grade 8 and 9. So I want to just show you how to do that quickly. And there are actually 3 ways in which to type in anything with scientific notation. Okay, so in terms of typing in things, you can just say times 10, literally, to the power of let's make it bigger, 7. Or you can type in like this, where you say second function and then you've got 10 to the x. So just types in the 10 for you and gives you the exponents. Or you can use this EXP button. Most people are not comfortable with the EXP. It makes them feel weird. It's just an older version of the times 10. It's just a space saver. And so it will give you that solution. Now, you also need to be able to set the calculator so that it gives you your answers in scientific notation. So to do that, we press setup and we choose 1 for FSE, and that stands for fixed scientific and engineering notation. Okay, so if we want scientific, we would choose 1. We'd say we want 3 significant figures, and that will then give us our solution. You can see our solution is then written within E. That's why I introduce it here as well. It just means times 10 to the power of, and then our exponent is the 8. So just a different way to read it. And then, of course, to change back, we would press setup and choose 1 for FSE again, and this time just choose 3 for norm 1. And you can see it's gone back to that notation as well. Great. Any questions here? Are we okay? We're good. Fantastic. Okay, so number patterns. Now, when we talk through number patterns in grade 8 and 9, we talk about investigating number patterns. And so we can actually use our table mode on the calculator to investigate a number pattern. So for example, we're given the formula of 3 times x plus 5, and we press equals, 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 equals. And now, well, I should have changed the start to 1. But anyway, it doesn't matter. So when my input is 1, my output is 8. When my input is 2, my output is 11. When my input is 3, my output is 14. And you can go for as long as you like with those. Okay, so table mode is very nice for playing with. Now, if we're coming up with a pattern formula, so we've got 11, 14, and 17, we can see that we are adding a common difference of 3 or each time. And then to find C, we subtract the value of 3 from 11, which gives us 8. So our formula is 3 times our position plus 8 over there. And that works. And we can, again, go back and test that on our calculator. So we're going to say we've got 3n, which we use an x for instead, and plus 8. And we've got 11, 14, and 17. So we know that our pattern is correct, and we can continue on from there. We can find our different places where we can say, okay, what is term 10? And we can just go look on the table and find term 10 in that way. Now you can also do this with geometric patterns. So for example, here we can see that we're multiplying by 4 each time. So write 4, and A is just our first term. So that's going to be our first term there, which is 3. So we just write 3 times 4 to the power of n minus 1. Or you can also write 3 over 4 times 4 to the power of n. Oopsie. So when n is 1, then the 4's cancel out and we're left with 3. So that's just 2 different ways in which you write the geometric pattern. Again, we can check that this is in fact correct. I'm not going to do it now because it's just repetition of what we did with the linear pattern, but you can go and try it yourself with your own calculator as well. Cool. Any questions so far? We good? We're still happy? All right, great, fantastic. Okay, so functions and relationships. So with functions and relationships from grade 7 to 9, we have, well, we start out with input and output values, and we can show these input and output values or these patterns or functions in 3 different ways. In a table, like we did with table mode, in a flow diagram, which we have here, or with a formula, which we used to get to a table. Okay, you need to be able to have one in order to get the other 2. So here we can see our pattern is I put in 5, I add 10, and my output should be 50. Okay, so again, exactly the same way we did with number patterns, you would type in your formula and your X would be your input, your answer would be your output. You can do the same with the geometric version as well. All right, so let's talk algebra and constants, because that's always a fun thing to explain to students. So we're going to jump back here. We're still in table mode. And so what I'm going to do is in function 1, I'm just going to put in a value of 5. Okay, I'm going to go through and I'm going to look at my table and I can see that 5 doesn't change because nothing is affecting it. So no matter what I do on the side where the X is, it's still 5. Okay, so 5 is a constant because it doesn't change. No matter what happens or what's going on in the world, 5 stays the same, it stays constant. However, if I make an X, okay, and I put it in here, we can see that while 5 stays the same, X is changing, and X changes because of what we're putting into it. Okay, so it's a variable. It changes based on the input that it receives. Now you can also use this to explain like and unlike terms. So again, in our table mode, I can put in an X, and this is often one that gets confused. And in function 2, I'm going to put in an X squared. Now, students often assume that X and X squared are exactly the same. And that's actually not true, because X squared is actually X times X. So when we go back and look at the table, we can see that while initially for 0 and 1, they are the same, from 2 onwards, they are completely different. The values are different. So that shows us that X and X squared are not like terms because they are affected differently by the variable. Cool. We also have a wonderful way to do substitution using your calculator and your memory keys. So I'm just going to show you both screens here so that you can see my example. So for example, we've got A has a value of 1 and B has a value of -3. And we want to find out how much AB squared plus A squared B is worth. Okay, so again, we're going home to normal mode. And then we're going to store the values of 1 and -3 into A and B. So to do that, we first press 1, we say store, and we press our A memory key, which is, you can see it's A above the Y to the X. Remember to use your negative button to make a minus, and then store that into B. Now, instead of trying to substitute all of these in, like this, so we'd have 1 times -3 squared, and that takes a long time. So what we can then do is just call our A, call our B squared, plus call our A squared, call our B, and we are done. So it's just saving on button presses. It also allows you to change the value in your A or in your B. And we can go back up and simply press equals again, and it will recalculate that value for you. Cool. So term 3, we look through, we start teaching graphs. And this is particularly nice for grade 9 when we want to start encouraging the intuitiveness or the idea behind your gradient and your y-intercept. Okay, so what I've done is in table mode, have simply put in an X, and I've looked at the coordinate pairs, and then I drew it on a Cartesian plane. Okay. Then I went back and I left my function 1 as an x, but in function 2, I multiplied the x by 2, and I looked at what's happening in my table. And you can see that the values in answer 2 are twice as big as the values in answer 1. And so when I draw this on my Cartesian plane, which we'll get to in a second, you'll see that it increases the gradient. Then I said, okay, but what happens if I multiply by -2 instead of by 2? So I changed function 2 to a -2x and looked at the values there in my table, and I plotted the coordinates here. So we can see f is the original x, so 1 to 1, y is equal to x, same. My g is my red graph, and that is y is equal to 2x. So in other words, I've doubled x for every y that I have. Sorry. My y value is twice as big as my x value is. For h, we can see that this is a negative. So what's happened is that I've changed my gradient. So what we can see is that the bigger our m value, or the bigger our gradient is for what we're multiplying our x with, the steeper the graph is, or the closer it comes to the y-axis. If my gradient is negative, it changes the direction of my graph as well. So then it flips it over to the alternate side of the Cartesian plane. We can also then do this with your value of c. So we could add 1, for example. We could subtract 1, for example, and then we could draw the graphs as well. And we can see from here, my original, which is just y is equal to 1, y is equal to x. Here with g, I've added 1, and we can see that the distance is the same. So it's shifted the entire graph up by 1 unit. And with h, I've shifted the entire graph down by 1 unit. So it's equidistant the entire time. In other words, they are parallel to each other. The gradients are the same, and the shift has now changed. We can also see that 1 is now bumped into our y-axis here, or -1. So we can see that the value of c, or what we added, is where we are breaking through the y-axis. So it's a really nice intuitive way to explain both gradient and y-intercept with your students, and you can have them explore. So this is GeoGebra. I've recently been introduced to Desmos, which is also a graphing tool, but apparently you can use it on your cell phone. So if you're looking for something fun where they can plot quickly, they can play around with, and you have access to tablets or to smartphones in your classroom or to a computer lab, then definitely I would say go and have some fun with Desmos or with GeoGebra. Learning through computers is often much more fun for students than just straight up drawing stuff. Okay, let's be frank. Okay, so Pythagoras. Let me show you this very cool shortcut here. So let's say, for example, you have a oopsie, that I definitely don't want. So you have a triangle, okay? The base, or the length of your triangle, is 5, the height is 12, and we want to find our hypotenuse. It's right angle triangle. So on the calculator, what we would do is we type in our x, which is 5, use our x, y in brackets button to create a coordinate pair, type in 12, and then press second function and 8. And you'll see above it in orange, it says arrow r theta. And what that is r is your hypotenuse, and theta, for those who are FET teachers as well, is the angle that the hypotenuse makes with the x-axis. Cool. Let's do basic steps. Any questions so far? We're still all good? Amazing, fantastic. So stats mode. Right. Let me just share both screens so you can see the example that comes up. So to get to stats, we're going to press mode and 1 for stats, and then we're going to work with 0, which is SD, is single data. Doesn't stand for standard deviation or any of that other I am just actually going to make up my own example here quickly. And one more. Okay. Okay, Khabo, I'll come back to your question in a sec. Let's just finish the stats. Okay. So here, you can see I've input, oopsie. You can see I did a double here. So what I'm going to just do is overwrite this and just write to 96 and press equals, and that will fix it. Again, if you made a mistake and you want to change it, so say for example, I want to change 17 to 71, you highlight the mistake that you've made, you type in 71 and you press equals, and it will overwrite it for you. Once you're happy with your data, there are two options. You can press on, or you can press, I've done it twice here. Let's change that as well. Let's just make sure I haven't done anything. Okay, cool. I'm pressing numbers. Okay. So once you're happy with your data, you can also press change, and change will just allow you to flick between your data and then your calculation screen as well. So then to find any of your information, you would say alpha 8 for stats and choose 0 for your statistics values. And then you have a summary of all of the information that you need for your statistics. So N is your number of observations, X bar is your average. We don't use standard deviation grade 8, 9, 7. You've got your sum of X, which is 563. So for those of you who want to use this in your teaching, you can just use the calculator's input marks as well and find all of your stats as well, your minimum, median, and maximum, and then of course your quartile 1 and quartile 3 values as well. So it's quite easy and straightforward to do. So I'm going to go back because the question for Pythagoras was, how will I know that the angle is adjacent or opposite? Okay, so when we're talking through opposite and adjacent angles, okay, so with regards to the Pythagoras, okay, we're talking the corner angle, and we're talking about the one that it works with the Cartesian plane. So it's always this angle that the hypotenuse makes with your x-axis, so that it's not necessarily that it's adjacent or opposite, it's that it's attached to the Cartesian plane. Okay, so here, because we're using polar and rectangular coordinates, it's always the corner one, and it's always to do with your x and your r value. I hope that makes sense, Khabo. Cool. All right. Then the last thing on the agenda is probability. And this is just a fun section. I know that we often get frustrated teaching probability. Awesome, pleasure. So this is a fun way to teach probability. And you actually have a whole range of random functions on the calculator. So again, we're going to go home. And this time we're going to press second function and 7. Then you'll see you have 4 different options. So random does random decimals between 0 and 1 to 3 decimal places. Our dice is exactly like a dice. So if you wanted to roll the dice, you would choose our dice and then just press equals, and it will just roll the dice for you. So this is really fun for things like creating tally tables with your class. So instead of having them all bring a dice to school, which can be quite crazy, and where we're supposed to experiment with dice, we can rather just use the calculator as a dice. There's a really nice fun game that I like to play with students. So what I'll do is I'll ask them all to raise their hands and show me the dice number between 1 and 6 using their fingers. And then if they chose the same number that is the number that was rolled in inverted commas on my screen, they are allowed to stand. And then we do the same thing again Usually takes 2 to 3 rounds before everyone is out again. And then, of course, you can do it with a coin as well. So either our coin is a math coin. So instead of heads and tails, it's going to do zeros and ones. So here, they would either choose a 0 or a 1, depending on, whatever, what you decide heads and tails are. And then this version of the game, so doing the same thing where your students choose either a 0 or a 1, takes a lot longer than the dice game. And it's a good way to talk about the reality of probability, because the chance of you getting it right on the dice is 1 out of 6, whereas the chance of getting it right on the coin is 1 out of 2, or 50%. So you have a much higher chance of getting the coin right than you do with the dice. And that's why it takes so much longer with the coin game than it does with the dice game. So from there, you can go into tree diagrams and all sorts of other really cool stuff. But it is a nice way just to work through probability with your students in a practical way. Another fun thing that you can do with them is to use your RNs and to actually play the lottery with them. So what I do is I have them write down the numbers on a piece of paper between 1 and 52, and they must write down 6 numbers. Then they switch their piece of paper with the friend sitting next to them or fellow classmates. And then what I'll do is I'll generate the random numbers on the calculator. So this is why it's really great. If you have a projector in your classroom, you can download the simulator for your classroom. It is free to download. I'll show you how to do that just now. And then you can also play that game with your students and see if anyone is lucky enough to win the lottery. So it's quite a nice exercise in terms of really exploring probability with your students. Awesome. So thank you so much for your time today. I hope that you found the workshop useful and that there were some tips and tricks in here that were beneficial to you. For those of you who are watching on YouTube, please like and subscribe to our channel. And of course, if you do have any questions, pop them into the comments and I will answer them as soon as I humanly can. Cheers, everybody.